The shipping industry plays a crucial role of constantly increasing importance for the global economy, in the freight as well as the passenger ship sector. The rise in the number of ships is accompanied by ambitious emissions reduction goals aimed at protecting the climate. To reach these goals, it is imperative to use fossil resources sparingly while stepping up use of regenerative energy sources. Ships have a very complex and intricate energy system. Viewed in isolation, the various components of this system have largely exhausted their developmental potential. In such terms, little room for progress is left when it comes to emissions reduction. A look at the dynamics of this energy system as a whole reveals a large potential, however. Targeted interaction of all components produces perfect performance. Diverse types of enterprises all play a role in the development of individual components. But joint efforts are needed if ambitious emissions reduction goals are to be reached. For this reason, renowned enterprises have come together and initiated the JOULES project to drive development through intensive interdisciplinary cooperation.
Leading European shipyards, component suppliers, academia and engineering consultants have joined the JOULES consortium to work out technical solutions complying with the challenging European targets for greenhouse gas reductions. Outstanding teamwork has led to a modeling capability that the maritime industry will benefit from for many years to come.
To get a better grasp of how the individual components interact and advance system development, the current state-of-the-art was depicted for 11 different application cases. On this basis, 2 future scenarios were drawn up. The first one shows possibilities for implementing emissions reduction by 2025. The second scenario shows how ambitious goals can be reached by 2050. Many technologies, for example fuel cells, are unable to replace conventional technologies completely in the near future. Thus, to start with, transitional solutions such as combined use of fuel cells and reduced diesel or LNG engines are called for. The use of new technologies poses new challenges for the overall concept. Can the new technology perform the tasks of conventional ones in full measure? Must additional components be developed, or are others no longer required? What changes must or can even be made to the supply infrastructure? Simulations serve to optimize future energy systems for ships and, on the basis of measurements and calculations, to assess the savings potentials of such systems in ecological and economic terms. Several demonstrators have been developed to depict and gauge the energy systems of the future. The collected data helps to develop reliable simulation models. One of these demonstrators is the ODOT program. ODOT stands for Operational Displacement Optimization Tool. This program focuses on reduction of transport weight in the tanks and optimal weight distribution on board, taking the ship's stability under all weather conditions into account. Less weight and optimally streamlined trimming generate considerable fuel saving. The program clearly depicts how much fluid, such as ballast water and fuel, is actually required for efficient operation of the ship and how best to fill the tanks for optimal weight distribution. The easy-to-install ODOT demonstrator showed a reduction of propulsive power of 6.7%. This is a promising result for the future. Another demonstrator is the Low Energy Cabin, LE-CAB for short. The concept behind the LE cab is based on decentralized air conditioning, as well as efficient electric consumers and weight reduction. The air conditioning units integrated into such cabins keep air from having to travel long distances through the ship's central air conditioning. Long conduits make air conditioning less efficient and pipes take up space. Weight reduction is primarily achieved through use of new materials and a self-supporting floor, thereby compensating more than the additional weight. The LE cab supplies most of the power it requires itself through transparent photovoltaic modules. And through a direct current system, the conversion losses are avoided. The LE cab demonstrator succeeded in reducing energy consumption significantly. The simulation results of the application cases were then used by the Life Cycle Performance Assessment tool to compare their future concepts with the current state-of-the-art from an economic and ecological perspective. The JOULES project shows that from a technical standpoint, it is possible to achieve considerable emissions reduction. Through ongoing research and developmental work, along with targeted support, the ambitious goals for 2025 and 2050 can be reached.
The integrated system design developed in the JOULES project revealed that solutions for significant greenhouse gas reductions are possible from technology point of view. We continue our efforts to design energy-efficient, eco-friendly and economically viable ships. This requires a political framework for a level playing field on regulations and incentives for prompt market uptake.